Good day, everyone. This is the week 15 that we are going to tackle about is the background music paging system. So the learning objectives that we are going to get in this topic is to differentiate between various sound systems, identify the basic components, analyze the specific audio requirements, explain the necessary system features, execute the preliminary steps, analyze ceiling speaker placement patterns, evaluate the need for combined mixer or amplifiers, and interpret and analyze practical system diagrams. So, incorporating digital audio PA and BGM background music is first a public address system is an electronic amplification system with a microphone, amplifier, and speakers used to reinforce a given sound. It is one system that allows a single user or group of users to address a large public number of people, typically in a venue or building. Second, a voice alarm system sometimes referred to as voice evacuation system. It is very similar to a public address system, and it is a system that assists in an effective evacuation of an area or building during a fire, bomb alert, or other emergencies. So the system application or first is the paging. Paging systems communicate voice announcements or throughout a building or area. Distributing intelligent speech is the main requirement of paging system. So speech energy is first concentrated in a range from 350 Hz to 5 kHz system frequency. The response should be smooth and consistent in this range. Next is speech intelligibility. It is the most affected by system performance in the range of 1 to 5 kHz. Consistent average of the listening area is especially important in the frequency range. Next is background music. Background music places different demands on a sound system than pitching. So the natural sounding music reproduction requires a minimum frequency response range of 100 Hz to 10 kHz that is wider than the basic speech range. The background music sources typically have limited dynamic range and have a lower peak volume requirement than foreground music or paging. The background music does not usually require the precise spectral balance and consistency of coverages as pitch, and this allows wider speaker spacing in background music only and systems. Next is voice music combinations. Most installed sound systems are required to produce both to reproduce both speech and music. So therefore, they must have both smooth response and even coverage of speech system and the wide frequency range and continuous output capability of a music system. Distributed speaker design. This means using good quality speakers and relatively close spacing. The safe management of buildings increasingly demand that the installation of public address or voice alarms or the equipment to respond quickly to emergencies. So the basic audio systems designs guide are the microphones, and as you can see, this is the block diagram of a PA system, the amplifier, and the speaker. So before you use the system, you must know the job they are going to do. So in every system specification begins with a survey of the site. The engineer, whose job is to ask the right questions and gather all information necessary to complete an accurate bid, normally performs the survey. So at this stage, it is most important to form an accurate picture of the customer's needs. Will the cost system is be used for paging, background music, or both? Do pages originate from a single location or from multiple locations? Must the system be tied into the customer's telephone network, or should the system be divided into multiple zones with separate port of controls? If so, should pages be routed to all zones, or should zones be separated the addressable? Should zone controls be located at the rack, or is local control required? The answer is to the questions like these will be determining major aspects of the system's design. So, talking to individual users of the proposed systems will help to reveal important design details. Is the major D hotel station located directly under the speaker? Or if so, then an independent local volume control should be provided for that speaker so that it can be adjusted to allow conversations with patrons while the person issuing pages be sitting under the near speaker. If so, then the consider equalization or a separate muting circuit to avoid feedback. Is the light switch height a comfortable location for zone or volume controls, or does the user have another preferences? Getting this kind of information at the beginning will help to avoid confusion and delays at the installation stage. Just as important as the human factors are the construction details of the site. How are the walls and ceilings constructed? What kinds of mounting surfaces will be encountered? And as is the drop ceiling a in type or tongue in groove? Where must cabling may be routed in? How accessible are those spaces? The partition walls are bearing members extend to above and drop ceiling, where they may obstruct cable runs, and is conduit or plenum cable required. All of these factors directly affect the price quote and the actual task of the installation. Next is the key is decision early in the evaluating equipment requires is what type of infrastructure the system should have. The key question is to ask consists of the following. Are there more than two independent audio programs running simultaneously? Second, are those zone specific independent remote controls required for volume in each zone? Third is the ability to remotely switch program sources for a particular zone required in more than one zone. Fourth, do voice pages and announcements needs to be restricted to certain areas of the building? Fifth is the remote off-site and control of the system a required feature. Six, what is the power requirements for the system? So step two, determine the acoustic requirements. When the basic infrastructure is established when a system acoustic layout can be done, this would consist of following basic steps. First, establishing requirements coverage areas. Second steps is setting the acoustic volume of SPL sound pressure level to levels desired. Third, establish any aesthetic or design requirements for the speakers. Fourth, estimating background noise levels for each zone. And fifth, determining the program material content to be run through each zone. So all this be done in while taking into account the expectation of the client and the environment in which the system will be run. Is it a loud sports for a bar or quite elegant restaurant, or it is a large open area of a hotel lobby and ballroom, or any of these needs can sway the final equipment selections. So at this point, you need to be determine the number of speaker appliances needed for the installation. So we're going to do the step three, conduct a preliminary layout and walkthrough. The third step is to assemble the system design on paper and view the signal paths, amplifier, power score requirements, and establish the basic functionality of the overall system design. So step four is to assemble the equipment list. At this point, an equipment list needs to be assembled and the hardware portion of the job can be estimated. Also, labor estimated can be done as well after a site inspection has been conducted and physical layouts to scale have been constructed. So upon completion of the through site survey, the system may be specified and coded. The engineer may also generate the design and code, often at the same time as the site survey. Success is the stage depends upon experience and product knowledge. So to avoid ambiguity and confusion at the state installation stage, the specifications needs to be as explicit as possible. Of course, it should enumerate all of the equipment proposed to do the job and should include both a block diagram and an accurate floor plan with annotations regarding construction. In addition, it should provide details such as local volume controls and height, um, the desired locations of arm procs, and even names of the employees who are expected to use the system. The forestall disputes to clarify responsibility if changes are required, and during after installation, the customer should be asked to sign a written agreement governing the specification. So in step four, many contracting companies simply communicate the sales engineer design directly to their installation department, who are charged with putting the system in and making it work. There are potential problems with this approach. For example, the salesman natural tendency to overin and oversell when he can. So, moreover, it is easy to make a flash oversell, and this may be compounded when a system goes in. To address these pitfalls, it makes good sense to have each personal proposal reviewed by a second engineering employee whose approval should be required before the specification goes to installation. At this stage, design details can be fine-tuned and potential problems can be addressed to assure that the design is feasible, efficient, and free of necessary redundancy. So yeah, we have the speaker selection. Distributed louder speaker systems for pitching and background music are among the most important and bread and butter jobs in sound and contracting. In most cities, new restaurants, hotels, and health clubs and clinics are continually sprouting up. Each one of us need that can be met by a distributed system, and each represents a potential client for enterprise and contractor. Next is ceiling versus surface mount systems. Several factors will determine the choice of surface mount or flush mount ceiling speakers for a given job. The most common criteria are audio coverage requirements, audio performance needs, building structure design, aesthetic requirements of the environment. Evaluating the choices among these primary criteria will often determine the format which is required for the listening area. And it's important to note there here that any installation may employ that both types of products for different areas or to meet certain performance needs. For example, to gain more control over sound coverage, surface mount speakers may be employed, but ceiling mount subwoofers may be utilized to keep the aesthetic footprint or design impact of the speakers on the space relatively small. Next is selecting and positioning ceiling loudspeakers. In the traditional approach to overload distributed systems, loudspeakers are located in a grid arrangement whose dimensions are dictated by the room, height, and directivity of the speaker elements. Two basic placement patterns prevail: square spacing and hexagonal or crisscross spacing. In addition to spacing patterns, the designer must choose between three density types, the designated respectively as edge-to-edge, minimum overlap, and center-to-center. The greater the overlap, the more uniform the coverage and the higher the cost. Budgetary constraints tends to favor sacrificing density to the optimum center-to-center configuration in practice, the least common of the three. So this is the diagram or the representation of square and hexagonal. So first is the grid in a square. You can see the edge to edge of minimum overlap and the center to center. In hexagonal, there is the this is the grid, the edge to edge, minimum overlap, and the center to center. Ceiling speaker coverage. The main objectives in deciding about the placement pattern and density of loudspeakers in a distributed system are covering the area effectively, providing sound that is audible and intelligible over the entire listening area, and making sure the system is capable of sustaining whatever average and peak sound pressure levels the application requires. So about the misunderstanding about the coverage angle specification of loudspeakers can easily result in system design mistakes. If this is common to see a polar coverage, spec can assume that the speaker will actually cover this angle. Loudspeakers actually cover less area than the spec sheets would imply. So to clarify that the coverage angle is typically the angle at which the sound level is 6 dB down from the axis sound level. So next is ceiling speaker coverage. Polar versus listening plane coverage. There are two different types of coverage measurements that often get confused for another. It is standard in a loudspeaker industry to state the coverage in a polar pattern. In a sphere that is 1 meter from speaker in all directions, the angle where the sound level is down to 6 dB from the on-axis level is called the edge of the polar coverage pattern. This is what appears on the spec sheets. It's legitimate specification, but it does not represent what is the coverage will be overall to flat listening plane in any room because it doesn't take into account the difference in distances that people are from speaker for speakers projecting from a ceiling into flat listening plane. The sound has to travel farther off axis to the sides than it travels on axis directly below the speaker, resulting in a much greater drop off of sound level of off axis. The result is the upload average of at negative 6 dB on the listening plane is more narrow than the polar spec. Some ceiling speakers manufacturers are use their polar measurement to claim extraordinary wide coverage. Do not use the specification to lay out coverage patterns of ceiling speakers.
An example of coverage pattern versus speaker size. For installation involving basic low-level background, music and paging system, designers are often specify 8-inch cone loudspeakers for distributed overhead systems, at least in part because they represent the traditional choice. In many cases, however, you can achieve an equal or better results at a significant savings by using specifically designed 4-inch elements characterized by somewhat smoother frequencies response and less susceptibility to feedback than 8-inch elements. 4-inch units are also generally less expensive, offer a real advantage in reduced directivity compared to the 8-inch elements. The use of subwoofers. Subwoofers are important part of an outstanding business music system. Light background or foreground music might not require subwoofers. However, even in systems where the bass doesn't need to be dominant factor, having a clear low frequencies can make the difference in the customer's enjoyment of the music. The number of subwoofers to use, where to position them, how to set taps on 70 volt over a or 100 volt subs, and how loud to run them varies depending on the characteristic of each installation. Criteria such as the speaker placement, boundary loading, are speakers placed close to wall or in a corner, the size of the room, coupling of multiple subwoofers, reverberancE of the room, the type of music, the type of activity, and the expectations of the listener all come into play. Positioning subwoofer. Components hanging a subwoofer in the middle of a room and results in lowest possible output from the subwoofer. Placing subwoofer at the ceiling, wall, or a floor increases its output. Placing it within a few feet of the two boundary junctions, like a ceiling wall junction or a wall junction, increases its output further. Placements within the 3 feet of a corner increases its output still more. In these cases, there is both an increase in sensitivity output per watt of input and in maximum total SPL capability. This can help in getting much as sound as possible from a few subwoofers. However, there is a potential pitfall in placing subwoofer in a corner. You can wind up with uneven bass coverage in the room because there are often so many or few subwoofers, so you can have a problem getting even coverage of the space. People sitting or standing very close to the subwoofer are going to hear the excessive lows, while people who are farther away might not getting enough sounds. Choosing the best mixers amplifier. Practical distributed sound system installation is almost always require the ability to handle multiple signal inputs. Pages may originate from two or more sources, the telephone system and handheld microphone. For example, a background music from two selectable sources with a muting keyed to the paging inputs may also be required. There may be a need for a low level new noise masking signal mixed in with the other signals at the consistent adjustable level. For those reasons, combined mixer amplifiers are commonplace in sound contracting, designed to handle several audio inputs at different signal levels and sources impedances such as units, incorporate mixing and automatic muting along with amplification. By efficiently consolidating often used functions in a single enclosure, they greatly simplify routine installations, reducing the cost and increasing reliability. Next, BGM and paging system designs. The following pages show a variety systems example using all components we have talked about in the preceding pages. preceding pages. These systems are practical real-world examples you can adapt to use your installation. So here are the examples of the o- here are the examples for us building office building 5 zone simplified systems. The other one is the equipment list. Here are the equipment list, model, location, description, and quantity. For example, we have speaker systems, the P4, PA430T, various paging home, and EVID C424, and the various ceiling speaker. The quantity of this is 2, as you can see in the example 2, and the ceiling speaker is 5. The pronouns equipment we have in the following with a 60 watt mixer amplifier, 4 by 100 power amplifier, paging microphone for the office and relay card. Here is the second is the bar restaurant K zone. Second, we have the bar restaurant 2 zone. Layout overview. This basic bar restaurant example illustrates a simple installation to control the three sources and two zones of audio within the 7,500 square foot building. It demonstrates the effectiveness use of DRM 4000 router for a basic two-zone BGM system. The two zones consist of the one of the bar area and the other main dining room. The systems also has a one paging station at the hostess stand and the three sources for a music tuner and television audio. As you can see in the diagram, we have the C2 server, sports bar, the radio tuner, the main restaurant, the office that is connected to a mic, also the hostess, the DPA4 4410 has a sports bar sub. And here's the equipment list in the example. Next is we have the large department store 6 zone layout overview. To extend the power of the pro-announced routing systems, the DCS control system can be used to page different zones. This system shown here uses an expansion in a large department store many independent programs and zone needed. This system can accommodate these requirements. As you can see in the system diagram, next, that would be all for my part. Thank you.